So for today's video lesson, you are going to be learning about systems of equations. And you're probably wondering, well, what is a system of equations? And the easiest way I can tell you to identify what a system of equations is to notice that when you read systems of equations, there is an S there. So on the end of equation, it's not one equation, it's going to be more than one equation. And that's exactly what a system of linear equations is. Two or more lines. At least for everything you're going to learn in Algebra 1, a system of equations, a system of linear equations is going to be two or more lines. So, for example, a system of equations, it would be y equals 2x plus 5 and y equals 3x minus 1. That would be a system of equations because it has two equations. The first equation is 2x plus 5, and the second equation is 3x minus 1. So the next thing, the thing that makes this super easy, is that when we're looking for the solution to a system of linear equations, then mathematically what we're looking for is the ordered pair, that works or that makes both equations true. So it's the ordered pair that makes both equations true. I'm about to do an example, so this will kind of make sense, but just mathematically, it's the ordered pair that makes both equations true. So that would be our mathematical definition of a system of equations. Now, in a graph, that's going to look a little bit different, and we're going to get to that in a second. But first of all, we're going to prove that 2, 5 is a solution for the following system. So if 2, 5 is a solution, then what that means is I need to plug in 2 for x, and I need to plug in 5 for y, and I need to see if I really do get 7, like it says I'm supposed to, if I actually get 7. So we're going to see what happens. So I'm going to replace x with 2. And I'm going to replace y with 5. And I want to see if it really is 7. So if I worry about the left side, 2 plus 5 is 7 on the left. The right side is still 7. And since my left side and my right side are equal, then yes, this works. 2, 5 is a solution to this particular equation. I'm going to see if the same thing happens over here. So again, I'm going to replace x with 2, and I'm going to replace y with 5, just like I did in the other equation, because remember, my x value that it gave me in the ordered pair was 2, my y value is 5. So I'm going to go over here, and I'm going to take, instead of x, I'm going to write 2. Anytime I take out a letter and put in a number, I need to put that number in parentheses. And instead of y, I'm going to plug in 5, and it equals negative 11. So if we do the math on the left side, 2 times 2 is 4, minus negative 3 times 5 is negative 15. On the right side, I still have equals negative 11. And then again, just doing the math, then 4 minus 15 is going to be negative 11. So the left side is negative 11 and the right side is negative 11. So since both sides were negative 11, then that means that 2, 5 is a solution. So because it worked for both of them and not just one equation, we know that 2, 5, the ordered pair, 2, 5, is a solution to the system. So a system, remember, is where it has 1 or 2 or more equations. So it's going to be a solution to the system, x plus y equals 7, and 2x minus 3y equals negative 11. And the way that we write that is with the fancy brackets. We did these when we were doing discrete functions earlier. So x plus y equals 7, and then 2x minus 3y equals negative 11. So that would be the final answer to our problem. That's what we would actually write. That would be our answer to question number 1. So 2, 5 is a solution to the system. X plus y equals 7 and 2x minus 3y equals negative 11. We're going to do the same thing for problem 2. It wants to know, is negative 2, 0 a solution for the following system? So I'm going to plug in negative 2 for x because that's my x value. And I'm going to plug in 0 for y because that's my y value. So we're going to see what happens. So on the left side, we'll have 0 equals negative 2 times, instead of x, we're going to plug in negative 2, because again, that's what we said our x value was up here, and then minus 4. So then on the left side, it's still 0. That doesn't change. Equals, well, negative 2 times negative 2 here is positive 4, and I still have minus 4. And on the left side, I still have 0. Equals, and then 4 minus 4 on the right side is going to be 0. So since the left side and the right side were both 0, it worked for that first equation. So now we do the same thing for the second equation. We're going to plug in negative 2 for x, and we're going to plug in 0 for y, because again, that's what we said x and y were over here. So I'm going to zoom in and work that out. So instead of y, I'm going to have 0 equals, instead of x, I'm going to have negative 2 plus 4. So the left side is still 0 equals, well, negative 2 plus 4 is positive 2. Since 0 and 2 are not equal, that means it's not a solution. So since it's not a solution to this one equation here on the right, that means that negative 2, 0 is not a solution to this system. So is negative 2, 0 a solution for this system? The answer to that question is no. And the reason it's no is because it didn't work for our second equation of y equals x plus 4. So it can't just work for one equation. It'd be like my black line and my yellow line here. So there's two lines that are on top of each other, so the lines are actually the same line. That's what it means to have infinitely many solutions, is that the two lines that you have in your system are the same line. So now you're like, okay, what does all of this mean? So look at number 3. Use the graph to the right to solve the system of linear equations. Check your solution. So remember, if I am looking to solve the system of linear equations, all I am looking for is the point of intersection. I'm looking for the point of intersection. So I'm going to go over here to my graph to the right, and I'm going to look at where these lines intersect. Well, they intersect, we can see they intersect right here. And this would be the ordered pair negative 1, 4, because we start at 0. And when I plot ordered pairs, we always go, I'm just going to write this here on the graph, we always go left or right first, and then we go up or down. So from 0, 0, I go left 1, and then I go up 1, 2, 3, 4. So that means that these two lines intersect, or their solution is going to be the ordered pair negative 1, 4. So that was supposed to be my answer. Well, the rest of this problem tells me I need to verify this. That means I need to plug it in. So that goes back to what we did earlier, where we plugged in a number for x and we plugged in a number for y. So in this case, my x is going to be negative 1. So every time I have an x, I'm going to plug in a negative 1 there. And my y is 4. So every time I see a y, I'm going to plug in 4. So I'm going to write that down here at the bottom. So instead of y equals, we're going to have 4 equals negative, and instead of x, I'm going to plug in negative 1 plus 3. So we're going to see if it works for that first equation. So the left side is still 4 equals. When I have negative, negative 1, negative, negative is really positive. So this is actually positive 1 plus 3. And just thinking about the math, if I add 1 plus 3, then I'm going to get 4. So I had 4 on the left side and 4 on the right side. So that means that this point, it'd be like my black line and my yellow line here. So there's 2 lines that are on top of each other. So the lines are actually the same line. That's what it means to have infinitely many solutions, is that the 2 lines that you have in your system are the same line. So now you're like, okay, what does all of this mean? So look at number 3. Use the graph to the right to solve the system of linear equations. Check your solution. So remember, if I am looking to solve the system of linear equations, all I am looking for is the point of intersection. I'm looking for the point of intersection. So I'm going to go over here to my graph to the right, and I'm going to look at where these lines intersect. Well, they intersect, we can see they intersect right here. And this would be the ordered pair -1, 4, because we start at 0. And when I plot ordered pairs, we always go, I'm just going to write this here on the graph, we always go left or right first, and then we go up or down. So from 0, 0, I go left 1, and then I go up 1, 2, 3, 4. So that means that these 2 lines intersect, or their solution is going to be the ordered pair -1, 4. So that was supposed to be my answer. Well, the rest of this problem tells me I need to verify this. That means I need to plug it in. So that goes back to what we did earlier, where we plugged in a number for x and we plugged in a number for y. So in this case, my x is going to be -1. So every time I have an x, I'm going to plug in a -1 there. And my y is 4. So every time I see a y, I'm going to plug in 4. So I'm going to write that down here at the bottom. So instead of y equals, we're going to have 4 equals negative, and instead of x, I'm going to plug in -1 plus 3. So we're going to see if it works for that first equation. So the left side is still 4 equals. When I have -1, negative is really positive. So this is actually +1 plus 3. And just thinking about the math, if I add 1 plus 3, then I'm going to get 4. So I had 4 on the left side and 4 on the right side. So that means that this point is a solution to that first equation. Now I've got to do the same thing for the second one. So for my second equation, again, it was y equals, so now I'm looking at y equals x plus 5. So instead of y, I'm going to plug in 4 equals, instead of x, I'm going to plug in -1 and then plus 5. Because again, that was the equation I was looking at here. This y equals x plus 5. So then I'm going to check my math, or fix my math, I guess I should say. So I still have 4 on the left side equals, so on the right side I have -1 plus 5, and -1 plus 5 is going to be 4. So since my left side and my right side are equal, this point is a solution. So notice that this ordered pair, when I plugged it in, I got check marks for both equations because my left side and my right side were equal. So that verifies that this point is the solution because it worked on both sides of the equation. So I'm going to work these problems out on the back. So number 4, I'm supposed to find the solution to the graph. So notice I have 2 equations, and I have a graph down here, so I need to graph these. So when I graph y equals -x minus 6, I'm going to begin at -6 on the y-axis. So remember, you can imagine the y-axis as a 1, because that's what you're going to do first, is you're going to plot a point on the y-axis first. So thinking through what ordered pair that would be, that's at -6. Well, -6 is kind of off the graph. Sorry, it's down here, but that's okay. We can figure that out. And then my slope for this problem, well, my slope comes from the number that's in front of x. So if I zoom in really close, it's a negative, and there's not really a number there, so that means I know that it's a -1. But I need slope to be in a fraction, so I'm going to put it over 1, because anytime I don't have a fraction, I can put it a 1 underneath it. So my slope is really, for this first one, -1 over 1. So directionally, I'm going to go down and I'm going to go right, because that's my rise and run. Or I can do the opposite of that, which is to go up and left. So I go over here to my y-intercept, and I'm going to go up 1 and left 1. And I'm going to continue that pattern, up one and left one, 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 and then I'm going to connect my dots, and that's going to give me my first equation. I'm going to do the same thing for the second one. It says y equals x. So whenever I have y equals x, my y-intercept, the number that's here on the end, there isn't a number there. That means that number is a 0. So there's really a plus 0 here. So that means I'm going to begin at the origin. So my first point for this graph is going to be at 0. And then my slope, again, if I don't have a number in front of x, that number in front of x is a 1. To make that into a fraction, I put a 1 underneath it. So if my slope this time is 1 over 1, that means directionally I'm going to go up and right. So I go back to 0 and I go up 1 and right 1, and up 1 and right 1, and up 1 and right 1. And I keep doing that as far as I can. Or I can do the opposite of going up and right, which is to go down and left. And then I connect my dots. And that gives me my second line. Well, if I'm looking for the solution, remember the solution we said earlier was our intersection. So if I'm looking for my solution, then I am looking for my intersection. And so I'm trying to figure out is where these two lines intersect. Well, you can see from the graph that they do in fact intersect. They intersect right here at this ordered pair, which is the ordered pair -3, -3. So my solution to this problem would be -3, -3. Now, I know that you're probably thinking, man, it'd be so nice if the calculator could do all of this for me. Well, guess what? It can. Okay, so if you want the calculator to do this work for you and to find this answer for you, then the first thing you need to do, so I'm going to write these steps down for you. The first thing you need to do is get both equations into slope-intercept form. You need both equations to be in slope-intercept form, which is y equals mx plus b. So you need to solve for y. Okay? When we say slope-intercept form, what we mean is we mean that you need to solve for y. So I'm going to write that here. Solve for y. Okay? The second thing that you need to do is you need to graph them. So put them both in y equals. You're going to type both of them in y equals. And the third thing you need to do is you need to graph them. Okay? You have to graph them because you need to see the intersection. You have to be able to see the intersection on the screen. And then you're going to press some buttons and it's going to do all the work for you. You're going to press the buttons. So our fourth step, you're going to press them in this order. Second, trace. You're going to press the number 5, and then you're going to press enter 3 times. So when you press second, trace 5, and then enter, 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 it is actually going to give you the intersection. Okay? When you press the button, second, trace 5, enter, 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 you will literally see the word intersection, and it'll tell you what x is, and it'll tell you what y is. So we're going to try that for problem 7. Okay? We're going to try that for problem 7. So problem 7 says 2x plus 3y equals -6 and y equals -1/2 x plus 3. So the very first thing we're going to do is we need to solve this first equation because notice it's not solved for y. So if I'm solving it for y, that means I'm going to draw my line, label my sides, and we're looking for what's on the wrong side of the line. Well, my 2x is on the wrong side of the line. When I move it over to the other side, it becomes a -2x. And then it's gone from the left side. And then to get rid of the 3 that's multiplied by y, I need to do the opposite of multiplying by 3, which is to divide by 3. So that positive 3 is gone. So I end up with the equation right over here to the side. Y equals -6 divided by 3, which is -2, minus 2x divided by 3, or 2/3 x. So now that first equation is in y equals form, and my second equation is also in y equals form. So right now what you should be doing is you should be typing them both in y equals. So in y1, we should be plugging negative 2 minus 2x over 3, and then in y2, we should be typing in negative 1/2 x plus 3. So once you get both of these in y equals, remember you're going to hit graph, so we're going back over here to our steps. So we're going to put both of them in y equals, and we're going to graph. You have to be able to see the intersection. So if you can't see the intersection, then what you need to do is you need to hit zoom out and then enter, okay? So if you can't see the intersection, then you need to zoom out. And make sure that once you hit zoom out and you go back to your graph, you have to hit enter again. Okay, so that's important that you hit enter. So you should be able to see the intersection at this point, and then you're going to press the button second trace 5, enter, 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 and it should tell you that your intersection is the ordered pair negative 30, 18. That's what you should get. If you didn't get that, please raise your hand and ask your teacher, because you need to make sure that you are getting that ordered pair. So now we're going to go back and do problem number 5. So number 5 says y equals negative 2x plus 2. So that equation is good to go, ready for us to put in y equals. Our second equation says y plus 2 equals negative 2x. So if I'm going to solve that second one for y, then I need to get y by itself, which means this plus 2 that's on the left side needs to end up on the right side, and that is going to make it a negative 2 on the right side. So now you're going to go to y equals, and you're going to graph your two equations, negative 2x plus 2 and negative 2x minus 2. And once you graph them, I want you to look at the graph, because remember, we have to be able to see the intersection. So once you graph these two lines and you go and look at the graph, this is what you should see. So we're looking for our intersection, and don't forget that when we're looking for our intersection, we're really just looking for we're looking for our solution, which means we're really looking for our intersection. Well, if you look at these two lines, they never intersect, so that means that there is no solution. So because they don't intersect, that means that there is no solution to this particular system. All right, we're going to do number 6 as well. Number 6, I'm actually going to, we're going to solve both these for y. So to get y by itself on number 6, I'm going to draw my line. My 6x is on the wrong side, so I'm going to minus 6x on the right side, so that means it's gone from the left. And then I'm going to divide by 6 to get y by itself. So that's going to give me the equation y equals negative 3 divided by 6 would be negative 1/2. And then if I have negative 6x divided by 6, that is going to be negative x, negative 1x there. So I'm going to do the same thing for the second equation. Again, I need to get y by itself, so I'm going to get rid of that negative 6 by adding 6x to the right side. And then to get y by itself, I'm going to divide by negative 6 for both of these. So then I get the equation y equals, well, 3 divided by negative 6 would be negative 1/2, and then positive 6x divided by negative 6 would be negative 1x. So I want you to look carefully at those two equations, and what you should notice is that they are exactly the same equation. They both say negative 1/2 and then minus 1x. So since they're the same equation, that means that they're going to have, their solution is going to be infinitely many solutions, because that means that these lines are going to intersect everywhere. So I'm going to mark that out and put infinitely many solutions. Okay, or you can just write the phrase infinitely many, but that means that they're going to intersect everywhere. So looking at number 8, we are looking for the solution to the system below. And remember, if I'm looking for the solution to a system, I'm looking for the intersection. So if I'm looking for my solution, all I am looking for is my intersection. So I already have a graph. I'm just trying to figure out where they intersect. Well, you can see they intersect here at this point, and that would be the ordered pair negative 1, negative 3. So my solution to this system is negative 1, negative 3. Looking at number 9, what is the solution to the system below? So I have some points here. I need to finish this line out. So in order to finish this line out, then I've got a couple options. I can either get a ruler and draw those two lines out, or I can use my slope, which is what I'm going to do to help me find the rest of the points on my line. So my slope, in this case, how I get from one point to the other, from here to here, I go down 1 and write 1, 2, 3, 4, 5. So I'm going to do that again. I'm going to go down 1 and write 1, 2, 3, 4, 5. And that's my next point. And do it again. Go down 1 and write 5. And do it again. And we do it as many times as we possibly can. That's as far as I can go. So that would be the rest of my line. So if I were to continue my line out, this is what it would look like. Do the same thing for the second part. I'm going to figure out my slope. Well, here's one point. Here's the other point. To get from one to the other, I go up 1, 2, and write 1, 2, 3, 4. So I'm going to repeat that process. I'm going to go up 2 and write 4. And up 2 and write 4. And I continue to do that over and over and over again. And I connect my dots there to get my line. And I am again looking for my solution. And if I'm looking for my solution to my system, I am looking for my intersection for my system. So I'm just trying to figure out where my two lines intersect. Well, when you look at the graph, you can see that they intersect here, and this is the ordered pair 10, 2. So my solution to my system would be the ordered pair 10, 2. Last question, number 10. A roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. In a second purchase at the same prices, the contractor buys 8 bundles of shingles for $256. The following system represents the situation for the price per bundle of shingles and the price per roll X of roofing paper. And we're supposed to graph the system and find the price per bundle of shingles and the price per roll of roofing paper. Well, we said earlier, in order to graph it, the first thing that needs to happen is I've got to solve for y. I need to get y's on one side, everything else that's not a y on the other. So I'm going to get rid of my 30y, I'm going to get rid of my 4x, and it's going to become a negative 4x. So that's gone. Then to get rid of the 30 that's in front of y, I'm going to divide by 30. When I divide everything, because division is equal opportunity. So y equals 1,040 divided by 30 is a decimal. So we want to leave it as a fraction, so we're going to reduce it. And if you do math inner, it's going to give you the fraction 104 over 3. And then negative 4x divided by 30 is also a decimal, so we're going to reduce that. And if you do math inner, it's going to give you negative 2 over 15x. So there is my first equation. Then for my second equation, again, I need to get y by itself. So I'm going to divide both sides by 8. And 256 divided by 8 is 32. So now that I have both of my equations in y equals format, I need to graph them. So remember, I'm going to graph them, put them both in y equals, just like we talked about doing up here. So I'm going to put both of them in y equals, and then I want to graph them, and I need to make sure that I see the intersection. Okay, it's very important that you have to be able to see the intersection. So make sure when you graph them, you're going to have to zoom out a decent amount to be able to find them a couple times at least. And once you've found your intersection, remember you're going to press the button second trace 5, enter, enter, enter. Second trace 5, enter, enter, enter. And it's going to give you the ordered pair. It's going to tell you that your solution is 20. It's actually going to say x equals 20 and y equals 32. So our problem wanted to know the price per bundle of shingles. Well, it told me up here that shingles was my y's. So that means that 32 is going to be the cost of my shingles. It also told me that roofing paper was my x's. So that means that 20 is going to be the cost of my roofing paper. So we just found our solution. So I just wanted to go over a couple, just a reminder of how to solve systems in the calculator, the buttons that you press. So to get the system, to solve the system in a calculator, you need to make sure you graph it and you can see the intersection, and you press the button second trace 5, enter, 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 or enter 3 times. There's a couple other buttons that are going to be important for you to note what they are and what they do. they're going to help you out as far as using the calculator. So the first button that you need to know about is Zoom 6. And what Zoom 6 does is it takes you back to your standard window. It's like your normal, like what you're looking to see. We could call it like our home, like what we are used to seeing when we graph lines in the calculator. It takes you back to your home. The second button that you need to know is you need to know Zoom 3, which is going to zoom out. Because sometimes you have to zoom out in order to see your intersection, so you're going to have to hit Zoom 3 to make that happen.